The first thing let's understand is what exactly is a linear equation. If you break apart the two words linear and equation, that pretty much gives you the clue. What is a linear equation then, Sage? An equation that gives you a an equation that gives you a line. Yes.
Yeah, that makes sense.
And the reason it gives you a line is for pretty much this reason. First of all, a standard normal textbook garden variety equation is one that looks like this. X plus 6 equals, I don't know, 10. In which case, you know the one single answer to that is what, Lucas? 4. X equals 4. Okay, there's no this, that, or the other thing. It's just simply 4. A linear equation comes from when you have something that looks like this. X plus y equals 10. Now, when you've got two variables, what happens is you can't narrow it down just to one answer, or there could be an infinite amount of answers. For example, if x, well, we usually do a table like this. If x is 3, 3 plus what number is 10? 7. Or if x happened to be 8, y would be 2. Or if x happened to be, here I'm going to throw a real wrench at you. What if x was negative 2? What would y be? 12. Okay. Because there's an infinite amount of answers to this, one way that we've come up to show those answers is to make them ordered pairs and graph them on a coordinate system. When you graph it on a coordinate system, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6, 7, 8, 1, 2, and negative 2, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you do this right, all of the points, the possibilities for this, all will fall on a line that looks like that. Mine's a little off because I put it on the board. Okay, this is a linear equation that gives you this line, and any point on this line is an answer that would solve this. For example, I'm going to guess if I found out where x is 5 on my thing, guess what y is going to be over here? 5 and what gives you 10? 5. So I'll bet if I go 1, 2, 3, 4, 5, and I go up 1, 2, 3, 4, 5, that's a point that's going to be on that line. Or if x was a negative 1, y would be 11. Let's see. If x is 1 here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so this line stands for any possible answer to that. Okay, now, what we're talking about today is a special, well, linear equations, except we are putting them in what's called slope-intercept form. Okay? Slope-intercept form, and there's a world of math out there that deals with this. Okay? And what slope-intercept form is, I'm going to go back to my x plus y equals 10 formula, or equation. Slope-intercept form, this is in standard form. Slope-intercept form is solved for y. Which means I just move the x to the other side of the equation over there, and it ends up looking like this. Y equals a negative x plus 10. Okay, this is in standard form. This is in slope-intercept form. Slope-intercept form is solved for y, has an x term there and then a number there. The generic way we show this, here's what you'll see in math for the rest of your life, is this. Write this down in big, bold, bright, beautiful text and color. Here is the slope-intercept form. Y equals m x plus b. When somebody talks about slope-intercept form, this is the generic formula for it. It's the form that it needs to be in. Okay, this is in slope-intercept form. So if I asked you what the letter B is, the letter B is always that number that sticks out at the end. And in this case, the letter B is, what's that number over there? 10. The letter M is the number that's in front of the X. So in my equation here, what number is in front of the X, even though you can't see it? What number do we, no, we don't put the number there because it's kind of an assumed number. John, it's a 1. And in this case, it's not only a 1, but it is also a negative 1. Okay. My letter B is the number that hangs out at the end. My number for M is the number that's right in front of the letter X. Okay. Don't worry, we'll go over this thousands of times if that really throws you for a loop. Now, why, you're going to ask me, are those numbers so important, and why is this called slope-intercept form? Sage, would you ask me that question, please?
Why are these numbers so important, and why is it called slope-intercept form?
Okay, it's called slope-intercept form because the letter M, right here and right here, in math, the letter M is the slope of the line. Have we done any slope stuff?
Yeah.
We have. And what is slope? Slope is the rise over the run, or how far up something goes for how far over it goes. Okay, and the letter B, children, is what's called the y-intercept. Now here's going to be a tough question for you. What does the word intercept mean? In the Army, okay, if there is a bad plane coming over your land, you will send one of your planes to intercept it, which means, no, not blow up. We're not blowing up grass here. Sage? Make it cross. Like, for example, here's the example. Here's the airplane flying into our bad airspace, and then we send our airplane over here. We want it to intercept it. We want it to cross, engage it at a certain point. Y-intercept is where it crosses the y-axis. Okay, I'll let you write that down. And then, ladies and gentlemen, we'll go back and actually look at the equation we just did. Back up a screen. So, with that being said, I'm going to change this, write this one back in my slope-intercept form. Y equals a negative 1x plus 10. If you look at the line that I just graphed here for you, it will cross the y-axis at 10. If I look over at the thing here, does it cross at 10? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It crossed the y-axis at 10. That's my y-intercept. What is the slope of this line going to be? Guess what? It's going to be a negative 1 slope, which means it's going to go up 1 for every 1 it goes over, but it's going to be a negative slope, and if you remember, negative slope goes downhill. So if you looked at this thing and you made a triangle out of it, you know, you can make as many triangles as you want. It's going to cross, here's a big triangle here, it crosses here at 10, and it's going to cross 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to cross here at 10. If you made a triangle out of this thing, it's 10 over 10. It goes up 10 for every 10 it goes over, which is 10 over 10, which is 1, which makes it a negative 1 thing. To which you're going to say, okay, but what real good does that do me, Sage?
What real good does that do?
Well, let me tell you. Okay, when you have something in slope-intercept form, okay, when you have something in slope-intercept form, you can graph a line really quickly. You don't need to draw the whole table thing. You can just look at the slope-intercept form, use the slope and the intercept, and graph a line without making a table. For example, y equals 1/2 x plus 3. Okay, how many of you just enjoy making an XY table and trying to figure out what times 1/2 when added to 3 gives you? You got to do like 8 or 9 different things. Most people besides John would rather not do that for homework if they didn't have to. And in this case here, we don't have to because we know this. The first thing we know is that the y-intercept is what? Remember talking about the y equals mx plus b. B is the y-intercept, so the y-intercept on my equation here is what? 3. Here's my y-intercept. What does that mean? That means if I'm graphing this, I had a board that worked. If I'm graphing this, I automatically can sit down and put the first point down because I know it crosses the y-axis at 3. 1, 2, 3. I put a point. That's the y-intercept. That wasn't so bad now, was it? Because you can do that pretty fast. The second thing I know is that the slope is what? What number comes in front of the x? Nathaniel Licht.
1/2.
1/2. Okay. Which means my line goes up 1 for every 2 it goes over. So here's the beauty of this. Starting, and here's where a lot of people go wrong, they start at the origin every time to do this. No. You start at the point you know, start here, big arrow, and from this point, you can just go up 1 over 2. Up 1 from that new point over 2. And right there, you've got all the points you need to draw your line. This line is the graph of this without having to do the whole table thing, without sitting down and doing any calculations. It's just right there. Now, the one thing you have to watch out for is this. Okay? One thing you have to watch out for is this. When I know that my slope is up 1 over 2, why don't I go up 1 over 2 this way? Because I certainly could have. And I could have gone up 1 over 2 this way and gotten 3 points and drawn my line like this. But why don't I? Corinne? Right, because if I did it that way, I would get negative slope and my slope is positive. So you have to think when you're going up and over, which way to go up and over so that you get a positive slope or a negative slope. I can tell by the amazement and the wonder in your eyes that this is just going to be something incredibly exciting for you. Let me show you another example here. Let's say I have y equals 3, well, let's go negative 3/8 plus x, 3/8 x plus, let's change that to, how about we go 3/8 x minus 7. When you find this and you're asked to graph this, okay, the first thing I would do is write down my slope-intercept formula, my generic thing. The second thing is I would write down what those things are. What is the y-intercept in that equation? What is the y-intercept? Rockwell?
7.
No, it isn't.
-7.
Thank you, it is. -7. What is my slope in that equation? Am I Haynes? -3/8. Given those two things, you can graph that line incredibly easily because you just need to do this. You always start with your y-intercept. What's it mean that the y-intercept is at -7? That means on the y-axis at -1, 2, 3, 4, 5, 6, 7, at that point, that's my starting point of my graph. I know it crosses the y-axis at that point. That's my first point. Now, what do I do with the slope there, John? I'm going to go up 3 over 8. You have to do those two things. I go up 3, don't put a dot at 3 because that's not what I'm talking about. I go up 3, 1, 2, 3, over 1, 2, 3, 4, 5, 6, 7, 8. And on your paper, you will have lines to do it. You're not kind of guessing like I am. To which you're saying, there's something wrong here. Is there not something wrong? What's wrong with what I just did? Lauren?
You made it,
I made positive slope. Catch on to that. Remember, if my line goes uphill, it's positive slope. What do I need to do? I actually need to go up 3 over 8 backwards. 1, 2, 3, 4, 5, 6, 7, 8. Here is my negative slope point. So then there from those 2 points I connect them, and that is the graph of this equation. Lucas,
yeah, so you start at the bottom.
you start at the y-intercept. In this case, it was at the bottom because it was a -7 intercept. So, intercept. If it would have been a +7, I would have started up here because it crossed the y-axis at +7. And then I just use my slope. Slope tells me how far up and how far over the next point is from that point. It was up 3 over 8. It had to be 8 this way because that gave me a negative line when I drew it there. Jackson. Perfect. Let me give you one. You've got a couple graphs on your paper. I want you to graph this one. Y equals 3/5 x minus 4. Graph that line on one of those 4 graphs on the bottom of your paper. Meanwhile, I am going to insert whatever file I can. Of course, these lines. This is lesson what? 56, right? You should be really done with it by now, actually. I'm just saying. It doesn't. You're not making any tables. You're just putting points. And by the way, a couple things. Make sure when you draw your line should go through your complete graph. You don't just go from point to point. You're graphing all of the answers that your graph will show. So you need to draw your line all the way through. Connect the points, but draw it all the way through. What was your first point that you started with? What was your -4? You put a dot there? So from that dot, you go up 3 over 5. What's that? Well, which way makes it positive? So, this is it, children. Here you go. You've got a nice graph. I just have this. The first step is to find, again, I would, if I were you, I'd write y equals mx plus b just to remind myself. B is -4 and the slope is 3/5. So here at -4, you put a dot. That is your starting point. Don't go back and start at the origin or somewhere else. Start at that point, and then you know that your graph will have to go up 3 over 5 positive slope. Up 1, 2, 3 over 1, 2, 3, 4, 5. And this will give me positive slope. By the way, if you run out of room, go on the upside. You can always go down 3 over 5. 1, 2, 3, 1, 2, 3, 4, 5. Either way, you will end up with a line. And like I said, don't just draw this. You need to draw your line through the entire graph because you're graphing all of the answers that would work for this. And that means you go through your entire graph. How many people feel that they have a small handle on the slope-intercept form of linear equations? It's not really hard. It actually makes your life a lot easier. Now, in addition to that, though, youngins, you also need to be able to look at a line and give what its equation would be. So taking a look at this right here. Okay, taking a look at, let's say, line A. Let's say line A. Line A. If I asked you to give the equation of line A, again, the first thing I would think is write this down, y equals mx plus b. The easiest thing to find is the b. Where does it cross the y-axis? Lauren?
-2.
At -2, if that's -2, it looks like negative. So you already know the b part. Now you need to find what the slope is. Okay? And there's no easy way around the slope. To find the slope, you need to make a triangle, a right triangle out of any 2 points that you can find. Fortunately for point A, you've got this point, this point, this point. If you take it and make a triangle out of this, how high is the triangle over how wide is the triangle? How high is it? 1, 2, 3, 4. How wide is it? 2. 4 over 2 reduces down to 2 over 1, but you don't need the 1 there. Now, then I have to look and make sure, is it positive slope or negative slope? It's going uphill, so it's positive slope, so I keep it just like this. Write down for me what line B would be. What is your equation of line B? How, what was your question?
If it were to be negative, would you just put
Minus sign, yep. What is the equation for line B? Again, start by writing the y equals mx plus b. You know what the letter b is. Where does it cross the y-axis? And the letter m is you have to make a triangle. How far up? Over how far over? Up, over, over, over. You will grow to love in your equations and slope and so forth. What did we come up with for that one there? Nathaniel Lick.
I got nothing at all.
You got nothing. Don't know where it crosses the y-axis or can't make a triangle. I don't know. Help me out here. You don't see where this line crosses the y-axis. Oh, what is it?
I'm still trying to figure it out.
Well, if this is the origin,
1.
yes, so you should have a +1 there because it's on the positive one side. Toughest part is usually finding the slope, and it's nice because this nice book has given you the points that you make your triangle out of. Okay, here is one triangle you can make. How high is that triangle? How wide is that triangle? 2. Is it a positive or negative slope? Positive, so you can just leave it as y equals 1/2 x plus 1. Now, it's not always quite that simple. Let me forge ahead here to the practice here. Here is part of the practice. Now, first of all, it didn't copy very well onto my screen. It's missing some of these lines here. Okay. If you were trying to find the slope of line E, okay, this is probably what people have the most difficult part about this, is they try to make their triangle just anywhere off in space. You can't just make it anywhere. You need to find a place where the line crosses both the x and the y-axis at a certain coordinate. In other words, this. I can't use this point here for line E because, yes, it touches an up and down line, but there's no sideways, there's no horizontal line that it crosses. So you need to find a place where it's an actual coordinate. For example, right here, that point right there, it crosses right in the middle, it crosses in crosshairs. I can give that coordinate. That coordinate looks like it's 1, 2, 3, 4, -1. Okay? And then I need to find a second one in order to make the triangle. So run your finger up it. It probably actually did cross right there, but I can't see that up and down line. So I'm going to find another one. Well, it looks like it crosses there too. Let's just go with, let's say it's this one right here, because I think it is. And those 2 points are the points that I would make my triangle with. It goes down, oops, goes down and over. And you'd have to sit there. Your book is much clearer than this, so it worked. How high is the triangle? 1, 2, 3, 4. How wide is it? 1, 2, 3, 4, 5, 6, 7, 8. So it has a 4/8 slope, which is 1/2, and it is also negative, because it's going downhill. So y equals negative 1/2 x. Where does it cross the y-axis? Right here at 1. That, ladies and gentlemen, would be the equation that you would use to find that one. Again, your book is a little clearer. It's not missing all the lines that I think would be here. Nick? Yes. You don't have to reduce it if you try to make the smallest one. Yeah, you would want to. And like I said, this probably did cross here. I didn't see it. And this would be the smallest triangle you can make. It's up 1/2, which is our 1/2 slope there. Jackson?
Do you also use the one up there?
Run up where?
Where?
Tell me when to stop.
Go over.
I could have stopped there. I could have stopped there. I could have stopped there. And I could stop there.
And when C goes down, and then
Well, I'm not doing C.
D over there.
You said that way you could have made a triangle.
Right here? Yeah, that's not on line E, which was the one I was doing. Okay. By the way, ladies and gentlemen, something else to throw in there. Special cases on this, you have a horizontal line. Horizontal lines, I think we talked about this. Horizontal lines have 0 slope. 0 slope. Okay. The actual equation of this line would be, it's y equals, there is no x, that's why it's 0 slope, because the x doesn't change. Well, the x changes, but the y stays completely the same there. No matter what x is, y is always going to be what? 1, 2, 3. Because no matter what number you put in for x, you're always going to get a 3 for y. And a vertical line, what do we say that was? The slope of that is undefined. You might want to write that down. And for reasons that I can't talk about right now, because I don't have the